And one of the more prominent solutions here is model-based development. So what are the software? I mean, these are the points again that we looked at. So I think we can skip through. I'll just read the headings over here. The changing requirements, quick time to market, increased complexity and functionality. There is very, very less number of skilled engineering resources to match high production costs. This is not only with respect to the software development, even industries like software design, machine design, system design, etc., etc. This is an problem that needs to be actually addressed. There are high reliability demands, and your software needs to be a lot more accurate. So we're all talking about, so you're talking about millions of lines of code, hundreds of lines of code. So what exactly happens here? Okay, so to put it into a context, a Boeing 747 jet has something close to 6.5 million lines of code. And a modern car, this is a Mercedes S-Class over here. A Mercedes S-Class has nearly more than 150 million lines of code, which is an equivalent of 500 copies of the works, complete copies of the works of Shakespeare. So this is again a representative image that I have over here. And again, about the variants that I was talking, you go to a General Motors, or you go to a Hyundai, you go to a Tata, or any other OEM for that matter. They just had, you say in 1993, I want to buy a Maruti 800. There was only one Maruti 800 that was available. You go, you see a Maruti 800, you buy, and you come back. Apart from Maruti 800, you have a Maruti Omni or any other car in Maruti, which is entirely different. But today, if you go to a Maruti Suzuki showroom, and when you're saying that I wanted to buy a Maruti 800 or a Maruti Alto, you have 3 different variants for petrol, 3 different variants for diesel. On top of that, you have a minimum of 2 variants for your automatic transmission. If you're going for a bigger vehicle like an SUV, you have a 2-wheel drive, 4-wheel drive, etc., etc., which means that you're going to have a 15 or 16 different variants for a single car. Imagine, like 20 years or 30 years back, you had only one single variant for one car. Today, you're going to have 15 to 16 variants for one car, with a different price range. So each of these cars have a different price range. With different price range, the different features also come into picture. A car which is like at 4 lakhs, which is a basic variant, won't have a certain features, but a car at 6 lakhs or 7 lakhs has it, as we all know. So a software engineer's job over here is to identify at the time of development, okay, this is the feature that I'm going to work on, this is the feature that I'm going to develop on, and he needs to work based on that. So if it is a manual process, as I had already told you, you need to copy, paste, and you need to do the whole job again and again. No, with model-based design and model-based design related approach, it's more of a very plug-in kind of a session. Like to put it in a much simpler term here, you have a model. Using switch related logics or something, you can switch across different variants and you can develop the software code. One active variant can be used for your project and the other ones can be commented out. So such kind of features have all come with model-based development, which actually makes the whole software development process a lot more easier. So this is about the ECU development costs that goes behind. As we all know, it's I mean, you know what's an ECU is. It's like basically it's a high-end microprocessor, microcontroller, which has a processor, a RAM unit, etc., with some memory in it, where you have to flash your software. So it's all about it's only like 30 to 50% is the cost of the hardware there, and 50 to 70% it's of the software that what you flash into it. Okay. So what are the reliability demands? Like this, again, we have been discussing at a long time. So now you would have had a fair amount of idea on, okay, a huge number of cars being manufactured. We can't spend a lot of time to manually write codes. Okay, so there is something called as model-based development, where we are going to develop some models. That models we are going to make it as code. And how to make it as code, we can see it in the future chapters. We're going to make it as code. Now we have to test them. How to test them, again, we can see later. How to validate them, how to flash them into your ECU, how to optimize them, and all that we can see. So here comes the reliability factors. Like we have already said, we have more than 70 million cars being manufactured. A study says that like a single individual car is being driven for 7 hours every week. and the average lifetime of cars is 18 years here. So you can imagine every day, I mean, every week a car is being driven for 7 hours. That is 52 into 7 for 1 year, and that is 52 into 7 into 18 is the average lifetime of a car. When you're looking at that for one car, there are millions of cars that is being manufactured in a year. It's just manufacturing count. I mean, we're not talking about the cars that is on road. And when you try to compute it and say the average runtime of cars on roads is like 10 times more than the flying hours of an entire Boeing 747 fleet. We are comparing the total number of Boeing since its manufacturing time, the total number of hours that is being fled around is like nearly 10 times lesser compared to the average runtime of a car, a single car. So if this is going to be the number of hours that a car is going to drive, just imagine the software quality, the physical component quality, the strength and reliability that it must have. Okay, so this, I was talking about the recall some time back. So this has the name of a few companies, like you can see here. Ford has recalled nearly 1 lakh cars here in the year July 2012. Volkswagen has recalled in December 2015 nearly 3 lakh units. So there are a lot of factors for vehicle recall, but the predominant factor that comes with the vehicle recall is the faulty software. Okay, I was talking about one of the OEMs, one of the cars, it was like rolling back when they are trying to move an automatic transmission car on a slope. That actually resulted, it was not a sensor failure, it was not a brake issue or anything, it was not a tire slip related issue. The issue was a faulty software. Okay, so this, when they fail to identify this, or when they identify at the last stage, the reliability goes for a toss. Now the next question comes is the new software that we have to give, we have to make it a lot more reliable. Reliability comes with pushing the software to a maximum limit of testing it. How are you going to push the software to the maximum limit of testing it? Comes along with the course. That is going to be discussed again at the end of our course. So okay, so we're all talking about a common question must arise among people. So like there are millions of cars that is going, you're coming and talking about something like as model-based development. Model-based development is an upcoming concept and all you're telling, but there are a lot of cars being manufactured. What is happening existing? How are softwares being developed and being dumped into your ECU, and how it is being tested? This is one of the common questions. So here we can all see like this, until I can say that until 2010-11, a lot of OEMs and Tier 1 suppliers were using handwritten codes. You all would have known about Robert Bosch. Robert Bosch until the year 2007-8 in all the top cars, in cars that were manufactured and sold in the year 2011 and 10. Those cars have the software and the ECU from Robert Bosch, and they were all using manual codes. You have engineers, huge number of engineers sitting down and writing the software. One of the major problems that the OEMs found with the manual coding process is that it does not complete very faster. One. Number two, the skill level that is involved is huge. You can only hire a software engineer. When you're going to hire someone with a computer science background, he might not have necessary knowledge of an automotive technician there. So they thought that, okay, when I hire an automotive technician and when I make them write codes, my job becomes a lot more easier. There is where the concept of model-based design came into picture. So this is an existing software development process with hand coding that was involved, where you have a software design, you write the code, you verify it, you validate it, you don't even validate it many of the times, you directly integrate it, you put it into a package, you flash it, and then you send it to the proving grounds for your vehicle to test. And then at the final stage, using onboard diagnostics data, they test, and if any issue is found at the very last stage, they come back. So there is a lot of time related factor that is there to start writing from a design stage to a final software stage. It nearly takes 3 to 4 months for a lot of people to work on it, and then when you flash it and test it, when you find an issue at the proving grounds, it's already nearly 5 months of time that is being lost. So how to make up for all of them? And the new features getting added and added, you have huge lines of code that is being you have number of lines of code that is being written. So how is all this is going to be taken care of? So then came one of the newer solutions which is model-based design, where you develop models based on requirement and concept. Whatever models that you develop, you simulate them. If there are ways to optimize it, you optimize it, you generate a code, and then you validate it. So this actually gave them a quicker, a lot more accurate results. When you're having a model, you develop a model, you can then and there see the simulation results. If there are any engineering related simulation results, immediately the developer or an engineer who is developing those models can contact the architect, who will fix the design. He will give him an updated design, so that the updated design can be now put into a model. He can validate the model. After validation, he can generate the code from the model. There are ways where you have a model, that model can be able to generate the code using some toolboxes. So that can be done, and then it can be taken to the further stages. So model-based design, as in we talk about as a V software development life cycle. It's called as a V model of software development life cycle. It's an iterative process where any design changes or conceptual related changes gets tested at every single step. So modeling, simulation, and validation here are the three main features of the model-based design. So model-based development and design is what we look at here. Modeling, simulation, and validation. Modeling is the virtual representation of your design and your problem. Your code is generated based on these models. Simulation is you have to test and see how your model behaves. Whether are you able to see the exact physical behavior of your design in your model. And validate is like, it's a very iterative process where you are going, I mean, it happens actually at the modeling and at the coding stage, basically at simulation stage as well, where it helps us, the validation helps us improve the quality of your final software product. And improved final software product means that we don't have any issues with the recall and other things, basically, etc., etc. So this is software development life cycle, V cycle. So we can start off with the left hand corner of your screen, which is the software requirement analysis. Usually there will be a program manager who tells that, okay, we have a certain feature that we need to develop. Okay, we have a feature where you would have seen this automatic window rolls up and rolls down. Okay, when someone tries to put their hand in the middle, the rolling up of your windows stop. So that, say we are going to develop that feature in a car. So your program manager basically comes with a software requirement analysis, something like, I have a switch, I press the switch, my window goes up. I press the same switch, my window comes down. It has an infrared sensor where if anyone is putting their hand or any object comes in its path, it must detect it. The signal must go to a sensor. The signal must go to the motor, and the motor must stop. Once the motor stops, the switch, that whatever it is pressed, it must depress by itself. So this is a requirement. This requirement will be given by your program manager. Usually companies have tools like rational clear case or any other tools they have by itself. You go to companies like Renault, Nissan, and Ford, they don't use clear case. There are other tools called as Jira and other things, which is basically a repository of your design and your development related changes here. So whatever changes that you do here, you call it, these are tools that are called as GitHub, ClearCase, and Jira. So different companies you basically use different tools. So whatever requirement that comes with you, whatever software design that you have, these designs are uploaded in your ClearCase or your Jira or GitHub, from where you have to download. The development team gets these designs. So the project is assigned to you. You are a team of 4 guys. Now you start working on the design. You have to sit down and understand what this is all about. What are the total number of sensors here? How many signals are there? And all these things go as a part of the design. Whatever query that you have, you can make a note of it. And I have already said it's an iterative process. So whatever designs or queries that you have, you can write right away. Like you can raise your hand and you can have a discussion with your program managers, get all your queries clarified. Then you can have a very, very, very simplified simulation model of your design. Okay, so after your simplified simulation model is designed, the next stage is like a low-level software development model. So now you have a simplified model that is designed. Okay, you're telling that I have a motor. That motor will actually, when it senses or detects any object in the between, it must stop. So your input signal is basically a switch. So a switch press is the input command that goes into here. So you're going to put a Boolean input to it. Okay, so Boolean input only takes 0 and 1. 1 is pressed, 0 is depressed. So these kind of understanding of your high-level design on a software level comes at the model development stage. So this software requirement analysis is the first, software high-level design is the next, and the third stage is like the software low-level design and the model development. So you understood the design thoroughly. Now you must replicate your design as a model so that you can try to test it, verify it, and take it to the next and further stages. So here, once your design is ready, along with the discussion of your team, you are going to develop a model. Okay, now you must identify, okay, there are so many signals that is going to be involved, there are so many variables that is going to be involved, so many calibration data that is going to be involved. Since you are saying that you have to control a motor, what is the voltage input that I am going to have for my motor? So what if my voltage value overshoots or undershoots in my motor? What if there is a sensor failure? How is it going to detect the diagnostics part of it? All these things needs to be taken care in this stage of software low-level design and model development. And taking all these factors into consideration, if a person develops that model has to be now tested. Okay, as far as the automotive industry is concerned, MATLAB Simulink is the front runner, or it's probably the only person who is involved in development of these models here, basically. Okay, you're talking about any design that has to be translated into a model. MATLAB Simulink is probably the industry forerunners. Companies like Robert Bosch used to have their own simulation tool, which was called ASCII, but I think they are no longer using ASCII these days. Basically, they used to have it, but they're no longer using. You go to any OEMs, like in Chennai, you have a lot of OEMs doing these kind of projects. Renault, Nissan, or Ford, or Value, or Labco, like anywhere you go, they all use MATLAB Simulink here. So as a part of this training, extremely high skilled MATLAB engineers are in demand in the industry. That's also something that we all have to look at. So the next stage of it is you have developed the model, you're trying to simulate it. Now you need to identify whether the model that I have developed with respect to the design, is it correct or not. So for doing that, you need to do model in loop simulation. I will give you a very brief overview of what a model in loop simulation will do, where you know what are your system inputs, you have a model, you know how your outputs are going to come. Okay, say you're giving an input of 1. Okay, let me take a very small example. You have a calibration data. The calibration data's value is 2. You're multiplying that calibration data with an input signal, where it is input signals range is going to be from 1 to 10. So 1 into the calibration data multiplied by calibration data value, it's going to give you an output of 2, and the final output is going to give you 20. So how are you going to now write test case for this is the question. So we all know that, okay, I'm doing a simple multiplication, my output is going to come, etc., etc. But things don't work like that. Things don't work in a very simple way like that. What you have to essentially do here is you have to write in test cases for a much complex industry related problems, where after writing the test cases, you have to test and see the model under different categories. You need to test it from a signal standpoint, you need to test it from a functional standpoint. Functional standpoint as in is that it's basically it's going to determine my voltage value. It must only have an output between 9 and 15 volts. So your output, your whatever input that you give, it should only be within the range of 9 and 15. When it is below 15, it must raise a flag. When it is above 15, it must raise a flag, and it's below 9, it must raise a flag. Something like that needs to be written as a part of your test cases, and such scenarios needs to be tested, and it needs to be there in your software. That is more important. And another So this is basically a functional level testing, and then a code level testing. I mean, a software level testing. Something is like where you say that the output must be between 9 and 15. You can give any data type for it.